Hi everyone. In this video, we are going to talk about operators in Python. Now, what is an operator? So, operator are these special symbols or keywords which are used to perform some operation on variables or values. So, example would be plus sign. So, when we add two numbers, we have this plus sign to add two numbers. So, plus is an operator here. Now, Python supports different types of operators. Let's first talk about arithmetic operator. So arithmetic operators are used to perform mathematical operations like addition, subtraction, multiplication, division. So if you have to add two numbers, let's say we have 3, or maybe I'll create a variable A, assign it some value, B, assign it other value. Now, if I want to sum the two numbers, I'll use plus operator for that. This gives me the sum. If I want to subtract two numbers, minus operator. If I want to multiply, I have the asterisk operator or multiplication. If I want to divide, then forward slash. If I want to look at the floor division or the quotient, you can say, I have this here. So this returns the quotient, two forward slashes. If I want to look at the remainder of this division operation, the modulus operator or this percentage sign we use. And for calculating the exponential, we have this double asterisk. Next, we have comparison or relational operators. These operators are used to compare values. So whether something is equal to something, a variable is equal to another variable or not, whether it's not equal to another variable, greater than, less than, greater than or equal to, less than and equal or equal to. So for all these things, we have different operators. Now let's look into these operators one by one. So again, we'll define two variables. Let's say x is 10, y is 20. Now if I check whether x is equal to y, this double equal is the operator. If you just use equal sign, that simply means that you're assigning the variable x the value which the y holds. But when you have double equals, it becomes your equal to operator. It will check for the equality here. And if they are equal, it will return the Boolean value true. But in this case, these values are not equal, so it is returning false here. If I check whether x is not equal to y, this condition is true, so it will return the Boolean value true. Similarly, we have greater than, less than. So if I check whether x is greater than y, so no, x is not greater than y, so returning false. Similarly, this one will return true. If I want to check whether x is greater than or equal to y, this will return a false. But what if I make my x 20? Now this condition is true. So although x is not greater than y, but it is equal to y. And similarly, you have less than or equal to. Next, we have logical operators. When you have multiple conditions that you want to check for, you can use logical operator. So example would be, let's say I want to disburse loan and there is a condition that the age of the person has to be greater than 25, greater than or equal to 25, and should be salary of the person. So second condition is salary of the person should be greater than equal to 40,000. Now, I want both the conditions to be true. So in this case, I will use the AND operator. So we have to disburse the loan, and for that, both the conditions should be true. So what is AND operator? So it will basically check for both the conditions. And if both the conditions are true, it will return true. Otherwise, it will return false. So even if one condition is false, out of the true here, out of the two conditions here, it will return a false. So and it has to be written like this, all small caps. Python is a case sensitive language. So yeah, this is the and. This is a keyword that is recognized by Python. This has a special meaning. This is a logical operator and. So in this, we have to define the value of the variable age. So let's say the person applying for the loan is 32 years old and their salary is 60,000. So in this case, because age is greater than 25 and the salary is also greater than 40,000, it is returning a true. What if one of the conditions is false? Age is 20. So this first condition is false now. So this returns a false. And what if all the conditions are false? Again, in that case, it returns a false. So both the conditions have to be true for AND operator to return a true. Now let's change our criteria again. And we say, okay, if the person is either like the age is greater than 25 or salary is above 40,000, we will disperse the loan or we'll sanction the loan. So in this case, we can use OR operator. OR operator, even if one condition is true, it will return a true. So either of the one condition is true, it will return a true. If both the conditions are true, it will return true again. Only when both are false, it will return a false. So let's quickly try it out. Here you can see both conditions are false. Age is 20, salary is 10,000. Both the conditions are false. So this will return false. And now let's go ahead and make one condition true. So maybe age I'll make 26. Now one condition is true. It's returning a true. Another one, uh, maybe I'll make this condition false. And this one I'll make 80,000. Is the salary. Again, it is returning a true. The third one that we have is the not operator under logical operators category. So not basically reverses the result. So this expression here is giving us the output true. Now, if you want to reverse it, we want to reverse the results, I can use the not operator and now it will return false. So whatever value we have, if we have true, it will give false. If we have false, it will give true. So let's try it. Let's just directly input true or false here. If I give true here, it is returning false. If I give false, the Boolean value false, it returns a true. So that's about the logical operator. The next one that we have is the bitwise. So whenever we are working with binary data, we would use bitwise operator. So this bitwise operator works with binary data, uh, which means that the operations are performed on bits of numbers. So you have AND operator here, you have OR operator here, you have XOR, you have NOT, you have left shift, you have right shift. So let's try it out. So let's say we have A is equal to 5 and B is equal to 3. Now, because the bitwise operator gets applied to the bits of the number, this has to be converted into binary form. So what is the binary of this? That is 0, 1, 0, 1. So 5 is basically 2 raised to the power 0 multiplied by 1. So 2 raised to the power 0 is 1 multiplied by 1 gives us 1. This is anyway 0. The next one is 2 raised to the power 2. So 0, 1, 2. So that is 4. And we add 4. So I'll just show you the calculation. So 0 multiplied for the first digit here. 0 multiplied by 2 raised to the power. This is 0, 1, 2, 3. Plus 1 multiplied by 2 raised to the power 2. Then we have 0 multiplied by 2 raised to the power 1. And then lastly, we have 1 multiplied by 2 raised to the power 0. Uh, that's how we convert decimal number into a binary. Now, this evaluates to 5. Just calculate this. This is anyway 0, this is 4, and this is 1. So 4 plus 1 is 5. Likewise, the binary representation of the number 3 here is 0, 0, 1, 1. Now, let's say I want to apply the AND operation, the bitwise AND. So we can do A and percent B. This is the operator. And it gives us 1. How is it doing the calculation? So for the AND operator, the rule is that if both the bits is 1, both bits are 1, it gives 1. Otherwise, it gives 0. So here, let's quickly see how this is working out. So basically, the first one is 0, 0, so that's 0. Then you have 1, 0. Again, both bits have to be 1. If either of the bit is 0, it will give you 0. Then third one also is 0. And last one, we have 1. What is the decimal representation of this? 2 raised to the power 0, which is equal to 1. And that's the output we are getting here. Now we have another one, which is OR operator. So let's try that out. For that, the symbol is this pipe here. Now, how does the OR operator work? So basically, the rules for the OR operator is, the rule for the OR operator is that if it's 1, 1, it returns a 1. If it is 0, 0, it returns a 0. If it is 1, 0, again, it returns a 1. So basically, if either of the two bits is 1, it returns a 1. Otherwise, it returns a 0. So if you have 1, 1, the OR will return 1. If you have, so this is the output. First bit is 1, second bit is 1, it returns 1. If you have 1, 0, it again returns 1. If you have 0, 1, it will return 1. And in case of 0, 0 only, it will return 0. So if either of the two values or two bits is 1, it returns a 1. Otherwise, it returns a 0. So if we calculate this, need to comment this, otherwise it will give an error. So yeah, this is coming out as 7. The third one that we have is XOR or exclusive OR. And here the rules are for this one. First, let's try running it. So here for this, the rules are that if both the numbers are 1, both the bits are 1, it gives a 0. If both the bits are 0, again it returns 0. If either of the bit is 1 and the other one is 0, if one bit is 1 and the other one is 0, it returns a 1 in the output. 0, 1 also, it returns 1. So if it is same bit value, it returns 0. If it is different, it returns 1. So let's run it and see what we get. 6. You can try doing the calculation like we did for the and the or operator, and you can see that it evaluates to a 6. Then we have the bitwise complement, the NOT operator. So it basically flips all the bits, invert zeros to ones and ones to zeros. And Python uses 2's complement representation. So the result for this would be the NOT operator. So let's just try running it. So for this, the sign is tilde, and it basically gives minus n plus 1. So here the value of n is 5. A is equal to 5 here, so minus n plus 1. So that evaluates to minus 6 here. Then we have left shift. So left shift will shift the bits left. So again, let's see this in action. So I'll do like this. So what does it mean? It means that we want to shift our bits. Let's just write that down. Shift the bits by n places. N here is 1. In this case, n is 1, 1 place, n places. And then we add zeros at the right. Once we have shifted it, we add zeros at right. So if we shift A, right? What was the binary representation before shifting? 0, 1, 1, 0, 1. So let's just write that down, 0, 1, 0, 1. Now we want to shift it. We want to shift it left. So how would it look like? So it would be 1 0 1 0. Why? Because we have shifted this right here. So this is this. We have shifted it left. Sorry, I think no. So this thing we have shifted, right? This 1 0 1, we have shifted it here. So this has moved here, the underlined part. And then there was this space which we have filled with 0, right? So what is the decimal of this? So this would be 10, right? So 2 to the power of 1 for this one plus 2 to the power of 3. That evaluates to 10. So that's what we are getting in the output as well. Okay, and similarly, we have right shift as well. So it's the same concept. It will shift the bits right by n places, whatever n. It doesn't have to be one, whatever number of places you want to shift it, and it will add zeros at the left. Okay, so that was about the bitwise operators. Now let's talk about the assignment. So assignment we have seen. So if you want to assign a value, let's say x is equal to 10, this will assign the variable x the value 10. If you want to basically, okay, let's try this plus equal. So this is like a short way of writing. So if I say this, right? So what am I saying? Let's just assign some value to x as well. And let's go ahead and print x as well. So this, what are we saying? That we are giving x the value 5, and this is equivalent to writing x is equal to x plus 1. So if we evaluate it, the original value of x is 5. 5 plus 1 is 6, and we are reassigning the variable x the value 6. So either we can write it in this way, but this is more compact. So yeah, you can use this also, plus equal. This and this means the same thing. Likewise, you have other ones as well, where for the assignment operator, you have subtract and assign, multiply and assign, and so on. Then we have the identity operator. Identity operator checks if two objects refer to the same memory location. What does that mean? So if, let's say, I have A and A has value, so I'm putting a list here, assigning a list data type to variable A, and then B is equal to A. Now, if I check A is B, it returns a true. Why? Because A and B are referring to the same memory location. They're pointing to the same object. There is another one is not. So if I check here is not B, it will return a false because this is not true. A and B are pointing to the same memory location. They're pointing to the same data. If I create another variable, let's say C, and assign some other value, it's a new object, maybe I'll say 456. And then I say print C is A. So this will return a false because C is pointing to a different memory location while A is pointing to a different memory location. And different values are stored in those two different memory locations. So identity operator. And then we have membership operator. So membership operator checks if a value exists in a sequence. Sequence could be anything. Sequence could be your list, it could be your tuple, anything you can iterate over, you can go over. There are multiple items. Tuple, string is collection of all these characters. Again, you have multiple items there. So if it checks whether a value exists in a sequence or not. So let's say we have a sequence. We have a, maybe I'll create a variable with the name fruits and I have some fruits there. Apple, banana, and mango. I want to check if fruit banana is in the banana fruit is in this fruits variable or not. So banana in fruits. And what it will return? It will return the Boolean value true. Why? Because banana is present in this fruits variable. What if I try with some other fruit? Kiwi. It's returning a false. Why? Because it's not there. Not in is the opposite of it. It returns true if the value is not in sequence. So if I do not in, it will return a true. So that's it for the Python operators. We use it at a lot of places. Whenever we need to perform some calculations, some comparisons, we use it. I'll record some videos where we'll talk about how and where we can use it. If you found this helpful, please drop a comment. Thank you everyone for watching. See you in the next one.